Hello, I am Monica Bhambi, a student of Government Engineering College Ajmer, and we are here to talk on the topic reinforcement learning in machine learning. So, we will first discuss the definition of reinforcement learning. Reinforcement learning is a simple framing of the problem of learning from the interaction. It is automated decision making in the settings where we don't yet know how our system works. Reinforcement learning is learning what to do and how to map the situation to action so as to maximize the numerical reward signal the learner. In reinforcement learning, learner is not told which action one must take as in most of the machine learnings, but instead learner must discover which action yields most reward by trying them. Before digging deeper, we first have to learn some terminologies related to reinforcement learning. Here, the learner or the decision maker is called agent. The agent interacts with the environment comprising everything outside the agent. The agent and the environment interact continuously by the agent selecting actions and the environment responding these actions as a state. The environment also gives rewards to the agent, thus directing direct learning. The agent tries to find policy of the moves that maximizes the reward on the long run. Figuring out much of the agent needs to know about the environment is known as exploration, exploitations, and dilemma. Now, we will discuss the chronological order of reinforcement learning. How can an agent learn to choose the optimal action in each state to achieve its goal? There are two steps involved in it: learning from its interaction and rewards and punishments. So, in reinforcement learning, agent learns by interacting with the environment and observing the consequences of its actions in the form of rewards and punishments. The agent must be able to sense the state of the environment and to some extent and must be able to take actions that affects the environment. The agent must have a goal or goals relating to the state of the environment. The agent must be able to learn from its own experience. To understand it in a more better way, we take some examples. For example, a master chess player makes some moves. The choice is informed by the planning, anticipated possibly replies and counter replies, and by immediate intuitive judgment of desirability of the particular positions and moves. The adaptive controller adjusts the parameter of petroleum refineries operation in the real time. The controller optimizes the yield cost and quality of the trade-off on the basis of the specific marginal cost without sticking strictly to the set points originally suggested by the engineer. In another example, a mobile robot decides whether it should enter in a new room in search of more trash to collect or start trying to find its way back to its battery to the recharging stations. It makes its decision based on how quickly and easily it have been able to find its recharger in the past. So we can see by experimenting with actions or robots and taking consideration the results of its action, a robots learn how he should act in future. Elements of reinforcement learning. A policy defines the learning agent's way to behave at a given time. A reward functions defines the goal in the reinforcement learning problems. A value function specifies what is good in a long run, whereas the rewards determines the immediate intrinsic desirability of the environment state. Value indications, the term long-term desirability of the states after taking into accounts the state that is likely to follow and the rewards are available in those states. A model of environment mimics the behavior of the environment. Model are used for planning, that is, deciding on the course of actions by conspiring possible future situations before they are actually experienced. Now we will discuss the application of reinforcement learning in machine learning, how it is used. So it is used in robotics, games, auction and pricing, informal retrieval, industrial and automotive control, autonomous vehicle control, logistic, telecommunication network, sensor network, and finance. So, how reinforcement learning is implemented in information retrieval? So, I have given some pointers regarding that informations like user modeling and resulting personalization, exploratory search, online document ranking, multimedia retrieval like image, video, music, and recommender system, evaluation of ranking, and algorithm. Exploration versus exploitations. So we already know that exploitations and exploration is figuring out how much an agent needs to know more about the world. Okay, so how it is done? It is done using a bandit problem. You have a choice among n different options of the actions. After each choice, you receive a numerical reward chosen from the stationary probability distribution. The objective is to minimize the expected total reward over some time period, example, over 1,000 actions selection. Each action has expected or a mean reward which is unknown to the player. Now that you have taken multiple actions, so if you maintains the estimate of the action values and always select the action whose estimate value is greatest, then you select the greedy action. Or you are exploiting your current knowledge of the value of the action. If instead you select a non-greedy action, then you are exploring because this enables you to improve your estimate of the non-greedy action's value. Exploring is the right thing to do to minimize the expected reward on the one's play, but exploring makes the may produces the greater total reward in the long runs. In simple words, we will go for the action which has less estimated value. Balancing exploration and exploitation. So we know if we go in either extremes, we won't be able to have maximized or we can say most appropriate or desirable action. For that, we uses different methods to have most desirable actions. So these methods are greedy method, software softmax action selection, linear reward penalty, which is linear automated method, incremental computation of action value, initial value estimate, reinforcement comparison method, and pursuit method, and associative search. In this presentation, we have learned about reinforcement learning in machine learning, and thank you.